Okay. In this week, we will firstly continue with the exception examples. X4. First of all, the def foo is defined in here. The print foo begins, and bar, and print foo ends. Okay. And so def bar, print bar begins, and also integer values x, and the print bar ends. Okay. So we can create the try, we can call the foo, and also we can define the except with, but now with the value error and the type error. Okay, we can create what the tuple values of these terms, and so this exception catch both the value error and the type error. Okay, and also we can print the what the value error and type error. We can use it. In the previous case, we just write to the what the one exception, but we can create a more than one exception error in here. Print index error exception. Okay, and also we should give the print ends because our program is continuing. So foo begins, and the bar also begins, and the value error, the type error happening in here, just like this one. Okay, this is another syntax relates to what our programs. And also x5 should be given in here, just like this one, the def foo, and return ten plus value. We cannot collect or the sum with the integer and the string values. Okay, and so the try, we can call the foo, and also if we have this syntax, and then we just write also empty except, just like this one, and so this catching every error in the syntax, and so we can write the print for the what an exception occurred. Okay? And also the print continue. And so if I run this code, an exception occurred and the continuous is seen on this page. Generally, we use this syntax if we don't have any error kinds or the type of the error in here. For example, we can guess what the value error may happen or the type error may happen, but also we can add this exception to what we can catch the what the unknown type of the errors based on this concept. Okay. This is the exception mechanisms. So how we can use the exceptions in the different manner. For example, we can create the what the banner function is in here, and so if not is instance text with the type of the str, and so we can raise the sum error, type error in here, and so we can throw this error in order to what? In order to notify the user or the programmer, just like this one. And so if this is not the case, type of the len of text, and so we can print the text just like this one, and also we can add this. And so banner can be written as just like this one. See, Ankara can be seen in here, but the banner for example 100 in here. And so if I run this code, and so raise type error is throwing in here, just like this one. What happened if I choose the value error in here? And so just see that the value error is thrown by the compiler in here. And so we can throw the intentionally error to what? To notify our users. But just see that in that case we cannot continue to run the program. Okay, so how about this one? We can define another function in here with the parameters of the a, and so the print bar begins can be written in here. And so if not is instance a integer values, and so we can raise the type error, but with now we can give some special notification to the compiler or the interpreter or the user. It's given in here. Okay, and so if this is not the case, if a is smaller than 0, normally this is not a syntax error or semantics error, but we can raise the value error in here. The number cannot be smaller than 0. This is intentional. Okay, and also we can write the print bar ends. And therefore a, the print foo begins, and bar can be called with the a, and so print foo ends. Okay, what about this one? We'll try and show the foo 10.5 and show foo -1, and also exception can be added in here with the type error of the SE in here. If we assign this type error SE and so this exception can be read by the exception with the E arguments can be reachable with in this case, and so this returns to the to this phrase or the str value of the of the value parameters arguments. Okay, and also except value error SE, and so we can also again print exception with the parameters of the arguments 0. Okay, and so we can add also more final keyword in here, print ends. Okay, see, foo begins, bar begins, and exception, not int, are seen in the terminal because this is not an int. Okay, at this view, right? Also, we can remove this pattern here, and if we rerun, then the exception, the number cannot be smaller than the 0. Normally, this is not an error, syntax or the semantics one. But if we are using this pattern in here, and so we can condition our program to adding some new features to our base or the purpose of our program. For example, if you want to use the negative numbers, and so we can add this exception in order to warn to the user or the programmer. Okay, that's it. And so, what about this one? In the class, we can write the error class just like this one, exception, and we can give the pass. Okay, and so try a is integer values of the input give a value. Okay, so if a is smaller than 0, raise my error. can be called in here because it's a class, and so this class can be called by using the constructor values of the distance. Okay, and so the print a times a can be done by using the distance. But what about this one? Except value error must be assigned in here, and so we can add what this is not a number. Okay, and also except we can give right now the my error, because the my error is derived from the what the exception class, and so my error possesses the whole the function or the attributes of the exceptions. Okay, and so we can catch the our algorithm based on this number. The number is negative. Okay, and also we can give the finally keywords in here. Finally, see, give a value, for example 5, and so 25 finally can be given in here, and also we can give the astas, and so this is not a number. And also if we retry again this number minus 5, see, the number is negative. Did you understand the basis of the exception keywords in here? This is a special class to what? To catch the runtime errors. Okay, guys? Any question? The compiler knows the value error or the my error, because if you are using the what integer type, and so this integer type is overloaded with this exception values. Yeah, and so if we run this code, value error or the type error, our class already have these functions or the possessions. Okay, because if you want to create the integer value, integer is a class. str value is also a class, and so this class contains what the operator overloading or the exception overloadings related to this number. Yeah, do you understand that? Okay. This is not a natural property. If we define the new class, this is not a natural, but if you are using the built-in str, float, int, or bool class, and so this class also contains the what the exception mechanisms. Okay. Okay, and so in this case we will continue with the new topic in here with a with keyword. With keyword. But what about this? The with keyword is an important topic in the Python. You can see it everywhere in the Python. In Python, automatic sources elimination can be done using this keyword, which means that with keyword. Okay, in C#, using keyword is identical to with keyword. If you know anything about the C# programming engine, so if we are using the using keyword in the program, this is identical. And so if we are using the with, and for example, if you open it the another sources, text file or the PNG or the Excel file, if we use the with keyword with the special cases, and so this with keyword open and close automatically to Excel file or the PDF file or the JPEG. Okay, this is the basis for the what the key with keyword. Basic syntax is with it, and also as variable name should be given in here, and also we should give the suit. Okay. In professional, so this can be called the context management protocol, guys. This is the professional name for the what? For the with keyword. So how we can define the our basis in here. For example, we can create the sample class in here. Def init self print init func. Okay, and also def enter overload in here self and print enter func. This is an overload, and def also exit with the type of the self executable type, execution value, and also we can give the traceback in here, and so we can give the what the print exit function and also return false value. Okay, and def this self can be given in here, and so the print this func. Okay, so what's the meaning of the enter and the exit? Just remember the overloading mechanism in the Python. Print begins, and what is the syntax? With sample s s. Okay, and also we can give what the print suit in here, and also we can print the end. What happened if I run this code right now? What's the output of this code? What's the output of this code? In this code, firstly, just remember that the print begins is run. After that, the sample creation is created in here, and so init function is called in here. But if you are using the with and as keywords in here, and so this overload is called by automatically from the interpreter, and after that this enter func is calling in here, and after that the print suite is given in here, and also at the end of the with keyword the exit function is automatically called right now. It is just like the constructor and the destructor of the keyword. But if we are using the with keyword, enter creates this loop, exit closes and removes all the resources coming from the wrap in here. Do you understand right now, guys? Okay. This is the basic utilization of the with keyword to govern the resources of our program. Okay, so we can write another examples in here. Class file wrapper. Okay, and so def init can be written just like this one, and so we can give the path, and we can return to the num values in here, and also self f is equal to open path and we. Okay, we can create some text file based on the distance, and also we can write a def write self s and self f write can be called in order to write this s into the text file. Def close self f close. Okay, and also def enter must be given in here. These are the overload, and so the print enter func is written in here, and also we should return to the self right now. It's different. And also the exit overload can be written just like this one, self executable type executable value and the traceback should be given here, and also automatically. Just see that in this case, in the init, we open this file, but we need to close it, but we want to close it automatically, and so self app close can be called right now, and so the print exit function is calling, and so return false value should be given in here, and so to try with file wrapper with the name of the what, the test txt s f right, this is a test. Okay, and so also we can give the exception in here, print file io error. Okay, so if I run this code, enter func and the exit func automatically is called and also test txt is created with this one. See? Any question about this? Do you understand right now? What's the advantage of utilization of the with keyword? Yes. For example, Yara and Yara. This is what you are talking about. Okay. See? Yara test. And we can add the smiling, and so if we rerun this code, see? Okay. Now we need to build the examples of the file operation in Python. File operation. In the Python or the programming language, file is a section which includes the information related to variables, characters stored in secondary memory. Okay, because it's apart from the program. And also we have some basic file modes in here because we want to drive what are database based on this one, and so R is equals to the opens and read. If it does not exist, happening error. Okay, we have the file modes, and also R plus. Yes, I can copy off the distance because it's unnecessary. R plus file opens and read, but both read and write can be done. If this is not happening or they exist, and so we will have error. But the write and write plus is reset and open, deletes everything and rewrite with the initial values. Okay, and also A is an addition, which means that the file is open, and so for example if we have the 5 sentences, and so if we are using the A mode, and so we can add more sentences without losing any information in the current txt file. Okay, so how can we prove that? Just see that x1 f open can be given in here, test txt w, it's a written and so print file opens and f write this is a test 1 and also this is test 2 and f close must be called in here. Okay. See, file opens and so the test is given by with what? This is a test, this is a test 2, but what about this one? 90, 88, 99, and also we should give the new line in here. If this is the writing mode and so just see that the file is reset and rewrites with the basis of the what this write arguments. Okay, and so how we can eliminate the f close pattern in here? We can use it with the what? With the with keywords in here. Open test txt wsf and so for example for I in range of the 10, okay, and so f write the numbers given with the what with these terms, and so also we should give the new line and format I can be given in here, and so we don't need to use the close function in here because we are using the with keyword. And so if I run this code, test is changed with the what with these numbers. Okay, and also can give the what x3 with open test txt wsf. For example, we have the while true in here as input can be given to this pattern, give a word like now, okay, and so if s is equals to the exit, and so we can break, but until then f write must be called with what s plus new, okay, and so if I run this code, so test x, for example Mehmet, for example Ali, so in this case we need to break it, and so for example words and exit, just see that Mehmet, Ali and words are passed into the what of the test txt. Okay, any question? If there's no question, and so the with open, we can open the files with the what test txt with the r plus, okay, sf, and so s can be given in here f read 10, which means that the 10 characters are read, and also we can print the print s, see Mehmet and Ali, or we can read 100 characters, see Mehmet, Ali, words, and after that the null character is found in this case. Okay, we can read the specific characters by using the these terms. And also we can use the with open test txt and r plus, okay, sf, and so while true sf read 5 characters, okay, and so if s is equal to this one, and so break should be given in here, but if this is not the case, we should give the print s and new, okay, and so if I run this code, see Mehmet, Ali, word, s, what happens in this code? what happens? Could you analyze this code? Anyone? In this case, we read at each while loop 5 characters, Mehmet, and after that T, and after that Ali, and so this print is run on this case, and so the word, and so the S, right? And so we have the what, this new line is added into this one, but we can generalize this problem based on the what? Based on the R program, guys. Okay? For example, we can open the R program also, not Y. R plus SF while true S F read line can be pulled right now. Okay? And so after that, if S is equals to the null, and so we can break. But until then, we can print the what, the S and ends empty space. Okay? So if I run this code, the R programs is read, or the program file is read, and after that, this read is printed on the what, the terminal. Just see that. See? I have everything about the what, my program, even it itself. See? We can read the every file here. In the seventh case, we can write to what the width open, and I can copy all of these terms in here just like this one. If I and R plus can be assigned in here as F, and so for line in F, because we have the 5 characters in here. For this example, we read the 5 characters, but if we have the empty space in here, word, new line, S is assigned in here. Yeah. But the predecessor of the word is assigned in here. Yeah. Do you get it? We have already 5 red characters in here. Do you understand that? So, just wait, and this one, and so and remove this one. In this case, Mehmet, just see that Mehmet, right? And so S is equals to what, the 5, and after that we have the new one, and so after that just see that this T, and so after the T we have the new one, Ali, right? And so we have also a new one in here, and so this word actually this one, because we have the one new line character and word. Do you understand that? Because this test has the what, the new line character in here, and so the function read this one. This is why. Do you understand that? Okay. So in this case, we can write everything in a compact form in here. Just see. In this case, we have the same structure, but with what? With a for loop in here. Also, we can open our basis with the what? With this one. We can convert everything as a list in here. For example, we can convert everything in here. L is equals to the what? The list can be used in order to what? To F, and so print L and len L can be utilized in here, just like this one. See? We have the what? The 100 words in here, but this one is equals to the what? Is equals to the our program. But we can convert everything into what? The list elements in here. For example, let's see that. And so if I rerun this code, see 169, which means that we have the 106 elements are given in here, guys. Okay. Any question? If there is no question, then we will have a break. Okay.